Hi, my name is Rajiv Shah. I work for a company named Gigaspaces, and today I am going to demonstrate that how you can use in-memory data grid with transactional and analytics application together. And I'll also go in a detail about the how our one of the IoT customer is using the same features. So as you see that in near future there will be more than 11 million devices connected to some type of grid, as CEO of GridGear was explaining, and that is not even including phones and computers. It would be cars and train and trucks and all other devices. So how can you take leverage of those information and get the analytics out of that and do some type of transaction on top of it? So this is about our company. Our company is 18-year-old company, and we have a two main core product. One is Inside Edge, which is our flagship product. What it allows you to do is that it not only allows you to do in-memory data grid, but it also allows you to do Spark and analytics together. And when I'll go in a detail, I'll explain you that how can you can take advantage of Spark with Inside Edge. And here is the some example that how many customers we have it in Fortune 500 and other large enterprises. We not only have a customers in a financial or IoT, but we have a customer in many different sectors. These are only few sectors we have mentioned here because of limited space, but we have customers in more or less any sectors. Here is the list of customers whose name we can disclose, but we have many more customers. So if you can see here that we have a customer from financial world such as Goldman, SocGen and others. We also have a customer from IoT, another Fortune 500 companies like GE, and also bunch of ISV partners. Right now what is happening is that people would like to do a lot of data driven application, but only 23% of them are getting success, and we will explain you how we can help to increase that percentage. Normally what is happening is that when you have so many data, like if you have heard so many time in today at least, and also in past few days, that okay, you have a data which is hot data and also cold data. Now what would you like to do with that hot and cold data? How you can take advantage of those data in best possible manner by reducing your TCO and getting the return on investment. These are the three main areas we would like to be part of our. One of them, how can improve the such as it could be a trading application, IoT, airline or any other sector. How you can take advantage of your historical data. So as you know that many companies have spent lot of money on a Hadoop ecosystem. They have stored lot of data over there, but they are not able to take advantage of that. So they are not getting any return on that. So how can we help to do that? Also now when we are talking about the Hadoop or NoSQL database or traditional RDBMS database, how can you have just one single application or platform which allow you to connect to different data sources and get the insight or value out of it. So these are the few things, such as how you can get the big data to get the insight out of it, how you can get the real time insight, and also from that insight how you can take an action out of it. If I give a specific example, that in one of the trading event they were explaining that you are receiving so many data points from exchanges, suppose let's say ticker prices for individual symbols, Amazon, Apple or anything. Also you have some expert or quant people in your company who has created mathematical model out of that, but they are not aligned with that. So how can you take action? So whenever there is a new stock price come, how you can take how can you analyze that data and send an order to order management system without manual or human intervention. Here are the foundation of our IoT analytics platform, that how can you get the edge or low latency processing. Suppose if there is one of our customer is a train company, and what they have to do is that they have a bunch of like hundreds of train running, and they would like to get the data out of that. If I give a human or layman like example, that right now whenever we are getting sending package or receiving any package, normally when we go to UPS or any other website, we see that okay, we will receive our package in X hour. We never see exactly in next 10 minutes or 15 minutes, and that is the same problem companies are facing. So what they would like to do is that they would like to start sending a data from their individual locomotives, connect those data point with the vendor's information, and then allow vendor to have a real time reporting, such as PepsiCo and other big companies. They would like to know that where is their inventory, when their packages are coming to the individual stores from warehouses, and that is the exact problem we have solved for that train company. Here is some highlight about our product. So if you can see that we not only have a in-memory data grid, but if I go from top to bottom, we have a connector to all machine learning and deep learning. We, as you can see, that TensorFlow, we are also working very closely with Intel for that big data, big DL. We also have a created bunch of application with there for their customers, like automated call routing center. I'll go in a detail if I get a chance to, or if I have a time. The next part is our in-memory data grid, and in detail if I go that as part of in-memory data grid, we support RAM and different type of storage also. We also have a full support with the different type of orchestration system such as Kubernetes and Cloud Foundry. We are also cloud native, and we have a customer running on a different platform. So this is the high level architecture about that, and if you see that when you see this architecture diagram, you see so many different components. So what I have done is that we have divided in a different category to simplify this architecture. So if you see that this is our core component, which is in-memory data grid and the multi-tier data storage replication, and then few others. So I'll go in a sequence, and at end I'll give some time, so I have questions for you. So here is our core component. So this is the in-memory data grid. So as you guys know more or less what is in-memory data grid, which allow you to store a data in memory. But I'll go in a specific detail why our product is better. So one of the advantage, I'll go in a sequence, that event processing. So as you guys have used database in your life at some or different form. So in a database they have a concept of trigger. So whenever you insert, update or delete a data, it allows you to take action. But whenever you use database and when trigger get executed, one of the limitation is that it can execute only function or stored procedure, and the context of that or boundary of that is a database itself. Whereas what we allow to do is that we have a concept of same thing called in-memory trigger. We call them a event processing, but benefit here is that it allow you to make a call to your business logic. So if I give such a simple example, which I go back to the trading application. So suppose assume that whenever you receive any stock price and it writes the price into in-memory grid, it can kick off your business logic, and from business logic it can decide what type of trade it would like to do, and then it can make a call to your order management system. The next one, which is data model. So as we have seen in most of the big enterprises, that they use different programming language, and many times I myself have faced the problem that okay, whenever I have a Java application and when I have to communicate with the .NET application, I have to go through some type of wrapper like JIntegra and then worry about conversion from Java to COM. And same way, if I have to go to geospatial API or JSON, it's even big headache. So what we have done is that as a part of our product, we have simplified that and take the burden on our shoulder. So what it means that if you have a .NET application and if you are writing a data in a grid, and when your Java client make a call to the grid, it doesn't need to worry or even think about it that who wrote the data over there. We transparently convert that object from one language to another language. Not only that, we suppose now companies are using MongoDB, so we also support the document based object, also JSON API and geospatial API. One of the example which you have heard is that now insurance companies are also start looking into digital or in-memory grid. So, to solve their problem, most of the time insurance company, the biggest feature they would like to know is that okay, whenever there is any hurricane or tornado happening, which area it's going to affect, or how it's going to, like what type of insurance they have sold in that area and how much would be their cost and benefit. To get that, what we allow to do is that you can write your POJO object, but from that they can create the geospatial query, right, and we do not have enough time, but I will give you my card and we can give a demo. So, what it allow you to do is that using the map you can narrow down to appropriate zip code or the area based on radius or dimension, that okay, in this particular area what properties are going to be involved and what should be the cost. So, those are the additional thing you can do. The next one which we have heard about the okay, what about the stateful application or what about the microservices. So, what we have done is that as a part of our product we also include the JT web container. So, it means that to co-locate your data and business logic, you can also deploy your WAR application as a part of our product. So, that way now your web application and a grid are running in the same JVM. So, now you can understand that what type of performance gain you will get, because there is no serialization, deserialization or marshalling, demarshalling. Not only that, the another benefit of this is that when you deploy regular application in any web container, suppose if you are using microservices, one of the known problem is that now when you go with the monolithic application to microservices, main problem is that okay, you could have one particular module which has a lot of burden versus other applications. Suppose inventory versus order management system has a different load. So, now that could be your bottleneck. So, what we allow to do is that as part of our product we have a dynamic scale up and scale down. So, when you deploy your application you can define your SLA, and based on your SLA our platform monitor the queue and it can start additional instances or reduce the instances and keep your SLA as is. Another benefit is that we also provide the redundancy and auto healing as part of our application. So, what happens that suppose let us say you are running microservices, you are running 3 node cluster for that microservices. In traditional world, if you have any of your instance goes down, someone has to manually intervene and start that instance, versus here as a part of our product you just define your SLA and we take care of auto healing and start necessary JVM instances and appropriate microservices. So, you do not need to worry about that. The next one is a RPC and MapReduce. So, as everyone knows that originally in a big data ecosystem to solve the Hadoop problem, MapReduce came and then Spark came, because Spark is much more faster over there, whereas we have that MapReduce concept from almost 15 years over there. Not only that, what we allow to do is that we have also fully integrated Spark, so you can leverage that. But if suppose there are many companies who are still not using Apache Spark, because part of Apache Spark is that it does not have a transactional support. So, if you would like to do the MapReduce with the transactional support, you can still use our product for the real time MapReduce versus the batch processing. Here are the few other features. So, our product has a linear scalability and elastic capability. So, as I mentioned that okay, we allow to scale up and scale down as a part of our product. As a linear scalability, suppose as your volume increases, you just add additional instances and it can maintain your SLA by spreading your load across different nodes. Next one here, the fast indexes. One of the best part of our product is that just like a traditional databases, you can put multiple indexes, also composite indexes, versus in most of the key value databases you could have only one index. And the next one is a no downtime and multi data center replication and fault tolerance. So, auto healing I just explained for multi data center. So, when you are using any databases, in a databases they have a concept of database replication from production to DR environment. Same way, as a part of our product, we also have a built-in feature called WAN replication. So, when you are running our product between two data center, your production grid is continuously replicating your data to the DR. So, that way without dependency to your database, you still have your data available. And not only that, the another benefit of this versus traditional database is, in database normally it is active versus passive, whereas as part of our product we support one directional and also bidirectional replication. So, that way if you would like to distribute your load between different data centers, you can still do that. Now, when I am going to demonstrate the Java Spark, most of the people are using Scala with the Spark. So, that way what we have done is that when you write an object from Scala or Java, you can use it vice versa. So, the next one, when we are talking about the analytics, what we have done is that as a part of our product, we have full integration with Spark. Not only that, we keep ourselves up to date. So, currently there is a Spark 2.3, we already have a full integration with Spark, and it is not only integration, but what we have done is that we have overridden the RDD, data frame and data set. So, here if you see that we are mentioning that it runs 30 times faster. So, I will explain you why. So, in a traditional Spark world, whenever you use RDD or data frame, the way Spark work is that it distributes your RDD or data frame across a different worker node, and whenever you want to query data frame or RDD, it has to go through different worker node, go row by row and return your result back, versus what we do is that when we overridden that. So, now we are storing your RDD and data frame in a grid versus your worker node. So, now your worker node are very thin, whereas your data is stored in a grid. So, now once we start storing data RDD and data frame in a grid, it means that we allow you to impose the indexes which is not supported by Spark. So, what happens that whenever you try to do RDD or data frame dot filter or sort, it does the predicate push down to the grid, and that way grid will return only required result. Not only that, your data is indexed. So, it means that it will run few times faster, and this can vary from 30 to 100 times faster based on your indexes and based on what type of query clause you have it. The next benefit is that SAD RDD versus data frame. So, when you are using Spark, the one of the limitation is that when your job is done, your RDD or data frame will be garbage collected. You won't able to use that across a different job, whereas here you have stored your RDD and data frame in a grid. So, it means that whenever your job is over, still that data is available. So, when your next job start, you do not have any burden, or you are not going to waste any of your compute cycle to recalculate RDD and data frame. Not only that, if you are running multiple applications together, you can still use same RDD and data frame across different applications simultaneously. The next benefit is that the RDD and data frame is immutable. So, it means that let us say if you have loaded 100 million data point from your HDFS database, now you want to modify only 5 rows. At that time, you have to recreate full data frame or RDD. It means that it will waste lot of compute cycle, it will take a time, and also there will be heavy garbage collection, and it can even have a stop the world garbage collection. Whereas here we have stored your RDD and data frame in a grid. So, it means that now those RDD and data frame are mutable RDD and data frame. So, it means that when you want to modify limited set of data, just like a transactional database, you can do it here. Not only, next benefit is that this is in-memory database, but it is fully ACID compliant. It means that you can have a different type of transaction isolation level, like read only, repeatable read, phantom read. All the transaction isolation level available in Java is also available in memory. The next one is a deep learning with Intel Big. As I mentioned that we have a strategic partnership with Intel. So, what is happening is that when people were using TensorFlow, Intel got very big heat on that, because more or less everybody use GPU for the TensorFlow, and that is why people were going with the NVIDIA. So, to overcome that, Intel came up with the same type of deep learning library called Intel Big DL to do same thing, but it allows you to do same thing using the Intel CPU, and they have written special math library called MKL. So, it means that if you think about the overall TCO perspective, Intel Big DL performs much better versus that. If you think about the absolute performance, yeah, TensorFlow is better, but if you think about the overall TCO, this one is much better. And we have worked with them for one of the major telecom provider who provide the call center to automate the fully call routing. What it means that if I give in a simplest language, we face this problem on day-to-day basis. Whenever we make a call to any customer service, it takes minutes and hour to get the real person, or if we get annoyed, we keep dialing either 0 multiple time or hash to get someone over there. So, it is annoyance on our side, but also very big cost on a call center company. So, what we have done is that using the deep learning, now using browser, you just speak your problem in a one paragraph, and using natural language processing, it can route your call to appropriate agent. Next feature is the distributed SQL 99 support and BI integration. So, what we have seen at many of our customers were asking us that okay, we are using the different type of BI tool, and how can we take advantage of your grid versus going through the database. So, what we have done is that we have a full SQL 99 support. So, from your Tableau and microservices, you just put your JDBC URL and then make a query against a grid. Our product is, like as I mentioned, more than 18-year-old. So, we have our own cluster manager, but what we observed that in past few months and year, most of the company have some type of big data presence, and they are using Apache Zookeeper. So, to simplify or ease their work, we have also integrated Apache Zookeeper as our cluster manager. So, that way they do not need to learn any new technology. And one of the biggest benefit of Zookeeper is that you always run in a odd number of node. So, it works very well in a split brain scenario. When we are talking about now terabytes and petabyte of data, what we observe that many companies doesn't want to spend lot of monies putting all their data in RAM, because most of the time that 20% of data are hot data, whereas 80% of data is a cold data. So, to overcome that scenario and reduce the total cost of ownership, what we have done is that we have also extended our support for the op-heap and also SSD storage. What it means that you can write the custom logic, and based on that you can decide that what data should be on your RAM versus what data should be on your SSD. And still when your data is in SSD, your indexes are still stored in memory. So, it will perform much faster versus traditional database. Also what we do is that if you are running a query for your cold data, and if you are querying only for the data which are part of your indexes, it does not need to go to SSD, because your indexes are already stored in a RAM. So, that way your query will still perform much better. Now, when we start supporting SSD, we saw that people have a different type of storage. It could be SAN, NAS, even for SSD there are different type of SSD. So, as Intel is our partner, what we have done is that we have done some performance benchmarking, and we have also observed that their Optane SSD perform much better versus traditional SSD. You are not bound to do it. I am just giving you the information that what could better as a product. The next feature is a data replication and persistence. So, one of the common question we always been asked is that okay, your product is a in-memory data grid, but still as a in-memory data grid your JVM can go down. How can we provide the persistence? So, as a part of our product, we already has a built-in module, and using Hibernate you just define your endpoint, and it can write either asynchronously or synchronously to any RDBMS or NoSQL database without writing any additional code. Now, another feature is that replication. So, what we allow to do is that we always tell customer to run at least one backup. So, it means that for each primary there is a dedicated backup. So, and always whenever you write your data to the primary, based on your SLA, it can either write synchronously or asynchronously to your backup. So, it means that whenever your primary goes down, it just change of responsibility, there is no data transfer. So, if you are running your query or if you are doing any transaction, you won't see any pause or delay over there. So, it can still maintain your SLA. And when we do the POC with our customer, we also demonstrate by intentionally killing our JVM and even hardware. We also have an additional feature that using SLA, you can define that your primary and backup should be on a different hardware. So, it not only can survive the individual JVM failure, but also it can survive the hardware failure. So, here the next one is that if you can see that okay, we have support to any type of cloud environment and also hybrid environment. What it means is that we have a many customer, specifically in the financial world, they note that they always have a X amount of node, but on a certain time period they have a spikes over there. To overcome that, what they are doing is that they have a fixed number of hardware in their on-premise infrastructure, but as and when their volume spike, it can create additional cluster instances on a cloud, scale out, do that transaction and bring the cluster size to the original one. The next one here, we are also Docker native. What it means that right now if you go to the Docker hub, we have our product image over there. So, if you have a Docker install, using our Docker documentation, you can write a 2 line of code and it will download the Docker image to your machine with the trial version and you can start using our product. Also, we are Kubernetes native. So, it means that initially we were using Kubernetes just for the orchestration, but now it is a totally Kubernetes native. So, it means that initially we were using our cluster manager, but if you want a Kubernetes native, you can use Kubernetes and pod and Docker to manage the resources. So, it means that with each, so the way it works is that you have a Kubernetes, then in each pod there is a single instance of Docker and that Docker itself is our JVM container. So, Zookeeper, which we are using for the cluster manager, it keep getting the heartbeat over there and using configuration you can define that what should be the delay. And whenever it found that okay, if any of your pod is not responding in a timely manner, it can change a responsibility, it can take this out, kill that processes. It in parallel to that it also make your backup as a primary and have your cluster as is running. Here is the next one. So, now what we observe is that many companies are using Lambda architecture, and in Lambda architecture normally they have a 2 type of parallel path going on. One is that this is the cold versus batch processing and this is hot versus the real time and transactional processing, and then they have to use so many different components. At end they also need to write additional component to combine the data they are getting from the batch and real time. So, what we allow to do is that when you use inside edge, you can replace both in a one part, because as a part of inside edge we have a Spark built in. So, whenever you receive all your data from Amazon Kinesis or Kafka or anywhere, using a Spark you can receive that data, store it to grid, and it has a Spark connector. So, using Spark connector it can connect to any of the storage, and whatever the connector not available by Spark, we have written those connectors. So, that way you can get your data from your Hadoop ecosystem or any storage, and also from real time, combine that data, run the query, and then get the result out of that, versus managing two different code base and then writing this additional wrapper class to get the data over there. So, here are some benefit, as you see that you do not need to worry about any ETL. It also has a built-in integration with S3 or any other data lake. Here another benefit is that now you have faster access to historical data. So, as in a previous event, someone was explaining that whenever they are using HDFS or Hadoop ecosystem, Spark has a limitation that okay, whatever the RAM you have allocated in your Spark, only that much amount you can get it, and also during the shuffle many times you need to spill your data, you have to spill your data to the file system. So, you get the performance penalty over there, which is all been overcome by our product. So, what I will do is that I will stop here, and these are some articles by different known agencies, and you can read that. So, what I will do is that I will stop here. If you have a question, I would like to take your questions, and if you still would like to know more, I will give you my card and we can do the follow up. So, any questions? Yes, absolutely. Yeah. I don't, let me see, normally in a microsecond, because our product are also used by financial companies, and I will give a specific example without giving a name. There is one of the top 5 bank in a US, and they are receiving the stock prices, futures, option, and different asset class price every day. They are receiving around like a 2 terabyte of data, and they are expecting 2 million IOPS per second, and average latency requirement was less than 20 microsecond, and they are using our product. But again, if you have a specific requirement, we can go in a detail and I can explain you that.
So, you have SSD storage.
Mm-hmm.
Also, you mentioned that this product can connect to a third-party database.
Yes.
So, if I have the data stored persisted in SSD, the local SSD,
Mm-hmm.
do I still need to persist data outside your system?
So, now when you are saying that you have store your data in SSD, but that data would be like as a text format, or how you have stored your data?
So, let's say like I have a JSON document.
Right.
So, in your architecture, right, I saw within your database, you have SSD layer.
Mm-hmm.
You can persist the data on SSD, and you call that a warm data, right?
Cold data.
In your slide, it showed reset.
Yeah, warm/cold versus hot. That's what I mean by that. Yes.
So my question actually is that does that guarantee data durability?
Mm-hmm.
In your database, or do I have to persist my data to third-party data?
You don't need to.
Okay.
You don't need to, and not only that, like what we can even demonstrate as a part of POC is that when you load your data from your regular SSD or regular database versus when you are loading as a part of memories extend product from our SSD, that's much faster, and many of our customers use our product just for the fast load.
Right.
So that way they can bring your system.
It's just like a parking night.
Exactly.
Right.
You are absolutely right.
Got it.
Yeah. We also have an off heap to avoid the garbage collection. You can also use our off heap product.
Okay. And also,
ideal node configuration, like what is your node configuration? Because you are mentioning SSD, memory, and all that. Bare metal. Like what is for the bare metal? What is your configuration?
So basically, we are hardware agnostic or cloud agnostic. So that doesn't matter.
SSD speeds depends, right? Like
So
you cannot use every, like say,
absolutely right.
like SSD read writes are different than different SSDs and
You are absolutely right. So, what we have done is that we have done the benchmarking with the Optane SSD, which is by Intel, and we observed that if you are using regular SSD versus Optane SSD, there was a 25% performance gain. Also, what we are doing is that Intel is coming up with the new NVMe, no exact. So, we are also working with them on their San Francisco division, because if you would like to get even better performance over SSD, NVMe is the better solution. So, it is like a price to performance balance act, like RAM give you best versus you go to NVMe little less, but you reduce your cost. As you go further, cost get reduced, but also performance decreases. And your another question was the primary and backup. That is more of a topology to provide the redundancy, because if you are running the single node like a single instance, you are just running primary without backup, then if any of your JVM goes down, then you need to reboot whole cluster, because now you have inconsistent data. Whereas, if you have a backup per primary, it means that if any of your primary goes down, let us say if you are running 5,1, it means that you have a 10 instances running, 5 primary and 5 backup. In worst case scenario, if all your 5 primary goes down, still your application is running as smooth as without any interruption. And also, because of auto healing, it will start another 5 JVM, allocate as a backup, copy the data, everything will done behind the curtain without you doing any effort.
So for your cluster, for your data grid,
Mm-hmm.
if the cluster is down, right, and when it restarts, is the data instantaneously available, or it requires some warm-up time?
So, that is based on what type of data source are you using and how much data you have it, right. Let us say if you are using HDFS and if you have 100 million object, it may take a time, but I will give you a specific example. We have one of the customer, airline customer, what they want to do is that they have to load 800 million object, and which was around 1K. So, it is almost 0.8 terabyte of data. So, what we have done is that because our product itself has a parallel processing, they were generating around like 10,000 files. So, in less than 8 minutes, we were able to load 0.8 terabyte of data.
So it is not instantaneous.
Yes.
Right.
Yeah.
Another thing is that I saw there are quite a few financial companies using your product.
Mm-hmm.
So could you tell us what kind of use cases they use your product?
Sure. So, one of the firm in the US who is responsible for option trading. So, as a part of option trading, what they need to do is that in an option, whatever, then whenever there is an underlying price change, they need to recalculate lot of price. If I give a specific example, let us say S&P 500 has an ETF called SPY, and SPY has an option for every single month. So, if there is any price change in S&P 500 happen, it need to recalculate almost 1000 different strike across different month, and each option has a call and put. So, it means that it has to calculate 2000 data point, and S&P 500 moves so much every day, and when there is like a Fed meeting or anything, it is crazy. So, what they were doing is that they were using our product, they are using our product to calculate the option risk management system. So, before that what was happening is that they have a compliance requirement that they need to recalculate price in certain time period, and also whenever certain move happen, they need to generate the margin call and send it to institutional investor and their broker dealer. And because they were not using any in-memory grid product, they were not able to calculate the risk in timely manner. But after they start using our product, that reduced drastically. So, they are able to do 4 times in the same window which is required by them. Also many other use case, but I can go in one to one after that. Like we have a trading applications been used.
Okay.
Yeah, so no problem. Any more questions? Okay. If If you don't have a question, thank you very much for stopping by.